In this video, we are taking a look at beginning with multiplication and looking at the different patterns. Again, we can understand mathematics if we kind of step back and look at the whole picture to see how all of the different pieces fit together, aka the patterns of multiplication and kind of what that means. And remember, each investigation starts with a problem. And you have to understand the problem because all of the problem sets that we work on are based off of that problem. And in this case, the problem is defined right here as a game that the math department at Everett Middle School is sponsoring, and it's called the number relay race. A number line is measured in meters, is drawn on the school field. Each team has 5 runners. 1, 2, 3, 5 stand at the negative 50. 2, 4 stand on the positive 50. So here's 2 and 4. Here's 1, 3, 5. Okay. Now they're running back and forth, and it tells you as they're running back and forth, Han right here starts at the negative 50 and runs to the 50, and then they just tag and go back and forth. It's like the shuttle run. But it's tag. You tag someone, they run back, and then goes back and forth. Right, Pascal then, the final person would be this guy right here, number 5. He runs from the negative 50 to the starting position at 0. So you have to understand this game, like what's happening, because that's going to take us into the idea of these patterns and multiplication to answer some of these problem sets that we have here. Okay, so the idea is to win, and it says the team whose final runner reaches the point 0 first wins, right? And you have 5 people. So person 1 runs this way, so that's 100 meter. And then person 2 runs this way, and when you're moving to the left, that's a negative 100 meter. All right, so you have to move left and right, and your last position would have to be 0. And so just to point out right here, at position 0 doesn't mean necessarily that it's the middle. It may, depending on the problem, but it just means that when these people are running to the right, that's a positive 100 meters. Running to the left, that's a negative 100 meters. And then when that last person, they're going to be at a negative 100 meters. When they're done running to the right, they're back at 0. Okay, so it's just like a shuttle run or a tag team race. So let's look at, this is based off of that problem. It says, write and solve a number sentence for each situation. Use positive numbers for running speeds to the right. So there it is, positive numbers. Write that down in your notes so that you know if they're moving to the right, it is positive numbers, and then negative numbers for running speeds to the left. Okay, so identify that in your notes. Write a little bit about this game. Put that number line on there so you can look at your number line as you're working on some of these problems. And then use positive numbers for time in the future, negative numbers for time in the past. And we'll get into that a little bit here as well. So in part A, Han passes the 0 point running 5 meters per second to the right. Where will he be 6 seconds later? So if he's running 5 meters per second, right, that's his rate of speed. That's how fast he's running, and he runs that for 6 seconds. How far has he gone? Right, so if he's running at 5 meters per second for 6 seconds, you just multiply those, and that gives you the total distance. And this is based off of the equation. Distance is equal to rate times time. We're going to be using that quite a bit here in... we're going to be using that quite a bit here in this chapter, and we're also, or this investigation, also the next unit as well. So write this down. The D represents the distance, the R represents the rate, the T represents the time, right? And here's your rate and here's your time, because it's 5 meters per second for a time of 6 seconds, and that gives us the total distance, which is going to be 30 meters. So it says, where will he be 6 seconds later? He's going to be at the 30-meter point, right? If he passes 0, so here he is, he's running, or she, I'm not really sure. So this person is running, they pass 0, running here at 5 meters per second, right? And then they're going to be right here at the 30-meter point. Okay, so that's our answer for that first one. That's where they're at. Make sure when you're writing these down, you know what that 5 represents. You know what that 6 represents. The 5 represents the rate at which they're running right here. The T represents the time. And when you multiply rate and time, that gives you the total distance, which in this case is 30 meters. Okay, try to answer the rest of these questions, B through D, on your own, and then come back. Pause the video, try them, and then come back and see how you did. So let's check to see how we did on B. It says Aurelia passes the 0 point running to the left. Now, because she's running, she or he is running to the left, that means that you're going to have a negative value right there. So a negative 6 meters per second times 8 seconds later. So that's in the future. So that's why it's positive. So the time is positive, but the rate is negative since they're running. So they're running left, which is a negative direction on this number line. Okay. And then on C, Dwayne passes, so we get, negative 6 times negative 8. If you think about where they're at, if they're running to the left, they're going to be over here at negative 48. So over here at negative 48, because if they're running this direction, right, at 6 meters per second, so negative 6 meters per second for 8 seconds, that's going to put you over here at negative 48 on that number line. So that's how we know when we take a negative 6 times 8, that's how we know our answer is a negative 48, because that's our position. Now, on, let's see, C, Dwayne passes the point running 4 meters per second to the right. And since it's to the right, that's why that 4 is positive. Now it says, where was he 6 seconds earlier? So that's back in time. And you remember in the original problem up there, it says, hey, if you are thinking backwards in time, then that's negative. So 4 times negative 6. So what this is saying is when he's running to the right, so he's running this way. Let me erase all this here. It'd be good to have this number line on your paper as well. So he's here, he's running to the right, right? And it says he's running 4 meters per second, running in a positive direction. But it says, where was he 6 seconds earlier? And so 6 seconds earlier is we have to think back in time. Right, and so that would be minus 4, minus 4, minus 4, minus 4, minus 4, 6 times for every second that he was back there. And that's where we are at negative 24 meters. Because where was he 6 seconds earlier? That's back in time. So when you would take 4 meters per second times 6 seconds earlier, that's why we have a negative. That's where the negative 24. And let's label it, label everything. So he's at the negative 24 meter point. And then on the last one, Tori passes this 0 point running to the left at 5 meters per second. So let's start this over. So running to the left at 5 meters per second. So running this way at 5 meters per second. And we know that is a negative because it's running to the left. So that is represented by a negative 5. And then it says, where was she 7 seconds earlier? So now we're going back in time. So if we think about 7 seconds earlier, so 7, 7, 7, 7, 7. So we go all the way back to 7 seconds earlier. That's like taking negative 5 times negative 7 because we're going backwards in time. Right? If you go backwards 7 seconds, so 7 times 5, that puts us over at negative, or at, in this case, since it's positive, actually right here, since it's positive, that'd be at the positive 35 meter point. Okay, so here we multiplied, we're going to the left and we're going back in time, but it ends up being on the positive side of 0 on our axis there. Okay, because you're going backwards in time. So then on the last question, determine whether the answer to each situation part 1 is to the left or to the right of 0, and that's easy. Listen, if it's negative, it's to the left of 0, and if it's positive, it's to the right of 0. So we had 2 of those that were negatives, 2 of them ended up to the left of 0, and then 2 of them were positives, 2 of them ended up to the right of 0. Okay, so now take that and put it into your own words to answer that question. And now with this one, we're tying in the idea of the chipboard, which we've used several times in the past to learn to add and subtract. And all multiplication is, as you've seen up here, like if we're going back 5 meters per second for 7 seconds, it's going to be backwards is going to be 5, 5, 5, 5, 5, 5, 5, 7 times, right? So minus 5, minus 5, minus 5, 7 times. And so it's just you're repeatedly adding that 5 to itself 7 different times. So multiplication is just repeated addition. And so taking that into consideration is, if it's repeated addition, then why can't we tie this into what we already know about these chipboards? So let's look at part B. It says, Kalman wants to use red and black chips to model the relay race. He draws the following chipboard to represent Aurelia's. I am probably not doing that name any justice, but it's this one right there. He draws the chipboard for her race or his race. How does this chipboard relate to your work on Aurelia's part of the relay race? Explain. Now, if you look at her problem, it says that she is passing 0 point to the left at 6 meters per second. Where will she be 8 seconds later? And because she's going to the left, that is a negative direction. And since it's going to be in the future, it's positive. So you're adding -6 to itself 8 different times. So just like this right here, I'll rewrite it down here. We had the distance is equal to -6 times 8, right? This is saying, hey, take -6, add it to itself 8 times. And that's what this chipboard is showing. -6 plus 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 -6. That's where we get the -48 meters. Okay? So this number is being added to itself this many times. Just like if you were to take 3 times 4, this number is being added to itself this many times. So you could do 3 plus 3 plus 3 plus 3. Okay? So that's how multiplication works, and that's how it ties into the addition. It's just the same number being added over and over and over again into what we now know is multiplication. And now getting into the big picture, looking at patterns, right? C and D really have you look at patterns of multiplication and kind of describing what sorts of patterns. So go ahead and try C on your own, see how you do, and then we'll come back and talk about these on C1 and 2. So do C1 and 2 on your own, and then we'll come back and talk about them. So if we look at number 1, looking at that pattern, you should have noticed that, hey, these products, as you go 5 times 3 times 2 times 1 times 0, decreasing by 5. So subtracting 5, and you should see that pattern. If you're going down, multiplying one less set or one less group every time, you're going to have one less set or one less group of -5 or of 5, right? So that's why the -5 is there. And then in 2, predict the following products. Well, think about what we've done, right? So if you know that 5 times 1 is equal to 5, thinking about, hey, now this, and the problem that we just did, the whole running thing, if we know that this represents meters per second, and the -1 means we're going back in time. So if we go back in time on a number line, if we're at 0, but we go back in time 1 second, and we know we're running at 5 meters per second, we're going to be at the -5 meter mark. Okay? So think about that number line, and if we go back in time, that means we're going back on the number line to the left of 0, so we know that our answer will be negative on that one. All right, and then D is similar, only it gets into, so think about what we did above. Think about what happens when, one of these is negative here. So like this is you're going -4 meters per second. Where are you at 3 seconds later, 2 seconds later, 1 second? So on the left, the -4 means you're running to the left. So if you're running to the left, starting on 0, where are you at 3 seconds later, 2 seconds later, 1 second, and so forth? Okay, and then try number 2 and predict what might happen with those. So pause the video, try these, and then come back. Okay, on number 1, you should have -12, -8, 4, and 0 on those, because if you're running to the left at 4 meters per second for 3 seconds, so if like here's your number line, you're at 0, and every second you run 4 meters, so 4, 8, 12, and you're to the left, that's where you're at 3 seconds later is at -12, and you can think of all of these like that. And then down here, now this is saying, so on the first one, let's do another number line, so here's 0. It's saying you're running to the left, but it's saying back in time, so 1 second prior to, right? So you're here, you're running that direction, but it says 1 second prior to. So if I back up 1 second, I'm going to be at +4, right? So 4 seconds or 1 second earlier, I was at +4. 2 seconds earlier, so I go back another second, which is another 4 meters, I'm at 8. And then 3 seconds earlier, I go back another 4, and now I'm at 12. So 3 seconds. So each one of these represents 1 second, 1 second, 1 second. All right, and we'll keep going back in time that way. Okay. So when you take these and multiply 2 negatives, you get a positive, right? You're going a negative direction, but you're thinking back in time, you're going to be on the positive side of 0. All right, and then go ahead and try to answer these 3 on E. Pause the video and come back and see how you did. Okay, on E1, if you think about what this means, this -4, that represents the speed and direction, right? So number 1 is going 4 meters to the left, 4 meters per second to the left. So it's running to the left on the number line. And this 12, this -12, since it's negative, it means where was this person set 12 seconds in the past. So if you're thinking about it on a number line, keep doing that. On a number line, right, so here's 0, and it wants to know he's running to the left, but they want to think in the past. So you have to go this way. Right, so we know our answer is going to be positive, and it's just going to be a -4 times a -12, and that's where we will get our answer of 48. And it's going to be a positive 48 meters, because we know that since we're thinking in the past and we're running to the left, that now we're going to be to the right of 0. 2 is very similar, but on 2, talks about... do this. It talks about, hey, now 4 meters per second to the right. So now you're running to the right, and then -12 means 12 seconds in the past. So if you're running to the right and looking in the past, did it again, my goodness. So here you are. You're running to the right, but thinking 12 seconds in the past, you're over here. It's going to be a negative answer, right? So 4 times -12 gives you a negative 48, in this case, meters, if you wanted to identify, because it does say what location. And then 3, how do the locations in part 1 and 2 relate to each other? Well, they're opposites. They're on opposite sides of 0. And so that's the one word that I would use. They're opposite each other. So that's how they're related. All right? Good. So again, the whole focus is on patterns. Try to get an idea of the patterns in your mind. Don't think narrowly into this lesson. Try to connect things that we already done multiple times in the past. How is the addition aspect, like with this board here, how is that included in this? So think of all of those things as you prepare to do this homework.